Hi everyone, welcome to our mathematics session. Today we will be focusing on how to calculate the area of a sector of a circle. You should already know area, circle, radius, and diameter. But let us take a look at what each word means. Area. This is the amount of space occupied. Circle. A circle is a round-shaped figure that has no corners or edges. Radius. This is the distance from the center of a circle to the edge. And diameter. A diameter is a chord that runs through the center point of the circle. It is the longest possible chord of any circle. Let us begin with this warm-up activity. We already know that in calculating the area of a circle, we use pi r squared. So let us use this formula to test our knowledge. Find the area of the circle using an approximate value for pi as 3.14. We already know that the radius of this circle is 7 centimeters. We also know that to find the area of a circle, we use pi r squared. So in substituting our values for pi and radius, we have 3.14 multiplied by 7 multiplied by 7, which gives us 3.14 multiplied by 49. When we plug these values in our calculator, we arrive at 153.93. And our answer correct to one decimal place is 153.9 squared centimeters. Let us try another one. We are given the area of circle Z as 96 squared centimeters. We are asked to find the diameter of circle Z. Now, what do you know about diameter and radius? That's right, the diameter is twice the radius. We do know to find the area of a circle, we use pi r square. Remember, we were given area of the circle Z to be 96 squared centimeters, and our approximate value of pi is 3.14. So in substituting our values for pi and area, we have 96 equals 3.14 multiplied by r squared. In transposing for r squared, since we do not have r squared, we have 96 divided by 3.14 equals r squared. In simplifying 96 divided by 3.14, we have 30.57 equals r squared. What do you think we are going to do next? Are you sure? That's right. We are going to find the square root of both sides of our equation. So it would be the square root of 30.57 equals the square root of r squared, which when simplifies gives us 5.53 equal r. Now is this our final answer? Are you sure? Good. So if we have our radius and we are asked to find our diameter, That means we have to multiply our radius by 2. So 2 times 5.53 gives us 11.06. Let us take learning a little bit further. We will now look at the area of a sector of a circle. But firstly, we need to know that the sector of a circle is a part of a circle, where the region is bounded by two radii of the circle and their intercepted arc. Let us take a look at the image. We have a minor sector and a major sector. If we look closely, we will see that the minor sector is the smaller of the two sectors. Since we know that the sector is a part of the circle, how can we find the area of the sector of a circle? If you were thinking that we will find a fraction of the area of the circle, you are indeed correct. Therefore, in finding the area of a sector of any circle, we would use theta divided by 360 degrees multiplied by pi r squared. Why 360 degrees, you ask? Think about it. That's right. The total degrees in a circle is 360 degrees. Therefore, our theta divided by 360 degrees would have been the fraction of our circle. How can we find the area of the sector of a circle? What shape does this look like to you? Yes, that's correct. It is indeed half of a circle. What name is given to half of a circle? Yes, it is a semicircle. Now, how do you believe or how do you think we would find the area of the sector of the circle? That's right. You would use half multiplied by pi r squared. But is there another way of representing half multiplied by pi r squared? That's right. The total degrees in a circle is 360 degrees. So if we are looking at a semicircle, it would be half of 360 degrees, which would be 180 degrees, which gives us 180 degrees divided by 360 degrees multiplied by pi r squared. Good job, guys. How can we find the area of the sector of the circle below? Look at it very closely. Yes, that's correct. That looks like a quadrant of the circle. Now, if it looks like a quadrant of the circle, how many quadrants does a circle have? That's right. A circle has 4 quadrants. So if we're asked to find the area of the sector here, we know we would find a quarter of the area of the circle. Good thinking. Now, if we did not want to use a quarter, what could we have said otherwise? That's right. 90 divided by 360 degrees multiplied by pi r squared. Now, can you tell me when simplified what 90 degrees divided by 360 degrees gives you? Yes, that's right. It is indeed a quarter, which means we could have used a quarter multiplied by the area of the circle, or 90 degrees divided by 360 degrees multiplied by pi r square. You are all correct. Find the area of the sector to the nearest hundredths. We know that to calculate the area of a sector of any circle, we use theta divided by 360 degrees multiplied by pi r squared. We also know that theta is 60 degrees. An approximate value of pi we are using is 3.14 and our radius is 6 centimeters. Substituting these values in our formula gives us 60 degrees divided by 360 degrees multiplied by 3.14 multiplied by 6 multiplied by 6, which when simplifies gives us 6 degrees divided by 36 degrees multiplied by 3.14 multiplied by 36. When we plug these values in our calculator, we arrive at 18.84 squared centimeters. Therefore, the area of our sector to the nearest hundredths is 18.84 squared centimeters. Good job, guys. Let's try another one. What is the area of this sector? We know that to calculate the area of a sector, we use theta divided by 360 degrees multiplied by pi r squared. We also know that theta equals 72 degrees. Our approximate value of pi is 3.14 and our given radius is 6 centimeters. Substituting these values in our formula gives us 72 degrees divided by 360 degrees multiplied by 3.14 multiplied by 6 multiplied by 6, which when simplifies gives us 1 degrees divided by 5 degrees multiplied by 3.14 multiplied by 36. When we plug these values in our calculator, we arrive at 22.61 squared centimeters, correct to the nearest hundredths. I am so proud of you all. You did well in class today, and you can now calculate the area of a sector of any given circle. I would love for you to get more practice at home, so I will leave you with 4 to try on your own. I will give you around 60 seconds to take them down. See you next time.